Welcome back. We're going to look at Pythagoras' theorem and solving some written problems. Alright, let's look at the formulas before we move on. The hypotenuse formula, c squared equals a squared plus b squared. C being the hypotenuse, a and b being the other two sides. And if we're finding a short side, we're looking at these two, a and b. A squared equals c squared minus b squared. Alright, optionally you can copy that down. If you think you've got that under control, leave it there. The steps I recommend you take in solving a Pythagorean problem are: read the question carefully at least twice, draw a picture if there isn't one and assign a variable for the unknown side, choose the correct version of the formula, either the hypotenuse version or the short side version, don't forget to take the square root at the end, and make sure you've answered the question that you were asked. A support wire is attached to an 8 metre vertical pole. It is secured to the ground 6 metres from the base of the pole. How long is the support wire? Apparently penguins can talk. So read the question again, make sure we understand it. A support wire is attached to an 8 metre vertical pole. It is secured to the ground 6 metres from the base of the pole. How long is the support wire? So now that we understand it, number 2, we're going to draw a picture. Start by drawing a pole. Now the pole's talking. Thanks, pole. Draw the ground and draw in the support wire. I've assigned W for the support wire. We can see that the support wire is the hypotenuse, so we're going to use c squared equals a squared plus b squared. Substituting what we know, W for the hypotenuse, 6 and 8 for A and B. 6 squared is 36, 8 squared is 64. Add them together to find out what W squared is, equals 100. Take the square root to find out what W is, and the square root of 100 is 10. So the support wire is 10 metres long. Have we answered the question? Yes, it's asked us how long the support wire is, 10 metres. Example 1. A rectangle has a width of 10 centimetres and a diagonal length of 20 centimetres. Find, as a third, the overall length of the rectangle. Following rule 1, we should read it again. A rectangle has a width of 10 centimetres and a diagonal length of 20 centimetres. Find, as a third, the overall length of the rectangle. So we have a rectangle, it's 10 centimetres wide, and its diagonal is 20 centimetres, and they want us to find the length. Let's draw a picture. There's a rectangle, there's a diagonal. So the diagonal should be 20, the width should be 10, and we're going to use L for length. We can see that L is a shorter side, it's not the hypotenuse, so we're going to use a squared equals c squared minus b squared. Substituting what we know, L squared equals 20 squared minus 10 squared. 20 squared is 400, 10 squared is 100. Subtracting them, L squared equals 300. Therefore, L equals the square root of 300 centimetres. We've answered the question because the question asked for it as a third, so we must leave it as the square root of 300. Example 2. How much shorter is it to walk from one corner of a 50 metre by 120 metre rectangular park to the opposite corner by cutting straight through the middle? Let's read it again to make sure we understand. How much shorter is it to walk from one corner of a 50 metre by 120 metre rectangular park to the opposite corner by cutting straight through the middle? So we have a rectangular park, it's 50 metres by 120 metres. There's a path going through the middle. So here's a park and a guy on a slippery dip for some reason. And a path through the middle, which I'm going to call P. And we know that it's 120 metres by 50 metres. So we can see the path is the hypotenuse of this particular triangle. So c squared equals a squared plus b squared. If we substitute what we know, p squared equals 50 squared plus 120 squared. Continuing the calculation, we get p squared equals 2,500 plus 14,400. Adding them together gives us 16,900, and then we take the square root to find out what p is, and we get 130, which should be our answer. But not according to that rhino. Why is it not the answer, rhino? Let's go back and read the question. How much shorter is it to walk from one corner of a 50 metre by 120 metre rectangular park to the opposite corner by cutting straight through the middle? Right, so the question's asked us how much shorter it is to take the path rather than walk around the outside. So thank you, rhino. Let's do that calculation. If we walk around the outside, it's 120 metres by 50 metres, so that's 170 metres. And we just found out that the path through the middle is 130 metres, so the difference should be 40 metres. And of course now the rhino approves. Alright, take a moment to copy that down. And as you can see, solving Pythagorean problems is easy enough. It's just a matter of interpreting the written information and creating a basic diagram, which makes it a whole lot easier to deal with.